lambda or mu, whatever you can. So let me take mu, m by L. So I want the time taken by the pulse to propagate from lower end to upper end. So find propagate from lower end to upper of a rope or string. Not a rod, it is a string. Okay, I'll start with a, let me assume a small element. At a distance dx. The weight of this small element will be dm. So what about the tension? Tension here will be T plus dt, and this will be T. Go back to laws of motion ideas. We will balance the weight of the small element. dt, this one, T plus dt will be balanced by T plus dmg. So at equilibrium for small element, dm is what? Will be mu dx into g. So let me, what is the tension at a distance x is given by T equal to mu gx. So I think we know in laws of motion, we have studied no problems of like this. So what happened to tension? As x increases, the value of tension will increase. So T equal to mu gx is what we got. So what is the speed of the wave? T by mu, where mu is linear mass density. So let me substitute this. So this will become dx by root x. So at T equal to 0, x will be 0. So time taken to propagate, T tension we took it, no? So let me write T only. So x to power of minus 1 by 2 plus 1. So minus 1 by 2. So this will be x to root x. So T is equal to, there's a time taken by the wave to propagate from one end to another end. Got the idea, no? Okay, what's happening to speed of the rope, speed of the wave? As it propagates, speed will increase, no? Speed will not remain constant because the tension is varying. So therefore, the speed of the wave depends on what? Depends upon the medium in which it is propagating. If the tension varies, the speed also will vary. Sir, how do generate pulse? You hold one end of the rope and give a jerk, and the pulse will start propagating here. The pulse will start the propagating. Okay, this is about the time taken to move from one end to other end. Okay, let's take next situation. Here only, let's have some small. Okay, Okay, there's a rope. I'll suspend a block. Mass of the block be m2, mass of the rope be m1. Let this be L. I will generate a pulse at the lower end. It will have a speed v1, lambda, wavelength lambda 1. When the same pulse approaches here, the magnitude, the amplitude will be same. But what will happen is the wavelength is going to change. So a pulse is generated at this one. How to generate pulse? Okay, let's not bother time being. Okay, the lower, now there's a rope of mass m1 and length L, and we have suspended a block or a particle or say every particle. Then at lower end, what I do, I'll generate a pulse. Then it starts propagating. So as it moves, what will happen to speed? So we know as tension increases, the speed will increase. If speed increases, the wavelength should increase. That's what I mean to say here. So 2 points which I'm more interested. So one, okay, I'll do one thing. This is m naught and m. I'll write it. It'll be easy for me. There's a point one. There's a point two. We know what is the tension at point one. M naught by G. Tension at point two. Is it okay? From laws of motion, the rope is having a mass, so therefore tension here will be m naught by G. What about tension here? The weight of the string plus the weight of the block. What is the speed? V1 should be equal to T1 by mu. Okay, got this. So let's divide V2 by V1. Then what will happen to, we'll set up, there'll be some source, let's not bother. So what is the frequency of the wave will be F. The frequency will not change. Frequency depends on source. Already we have discussed, no? So as we know, F is equal to V1 by lambda 1, F equal to V2 by lambda 2. So therefore, what is the new wavelength? V1 by lambda 1 equal to V2 by lambda 2. So what is lambda 2? Should be equal to V2 by V1 into lambda 1. So the new wavelength is given by, now will it increase or decrease wavelength? Lambda 2 greater than lambda 1. The reason V2 greater than V1. So as the wave propagates, as the speed increases, what will happen to its wavelength? Wavelength will increase. Frequency will remain same because the frequency depends on source, not on medium. Where the speed and wavelength depends on medium. I think I have to put that comment. Frequency of a wave depends on source and speed, wavelength. That to conclude this statistical idea, I just took this particular example. So what will happen to the pulse? The pulse which was generated, which was narrow, no, will become broad because lambda 2 will increase, no? Getting the idea? The pulse will become broader. A narrow pulse set up at the lower end of the rope, by the time it reaches the upper end, will become broader. I think correct statement. It's not a conceptual, it's a numerical. Through numerical development, we are able to conclude that particular point. So if you look at the S.C. Verma book, most of the questions which are their objective, no, they are not just mere reading. You should have a background diagram. You should analyze these things, huh? Not just you should read, okay, think and put and select the option. Maybe a background diagrams of like this is needed. There's a pulsar. I'll just show it. It will be no slowly. We are just discussing more about the pulse. And one more condition. Let the so now I'm having a rope where the linear mass density will increase. The linear mass density of the rope itself will vary. So this end is x equals 0, this x equal to L. Here a pulse is generated. How to generate that pulse? Again, I'll hold lower end of the rope. I will just move my arm, not up and down. I should move my arm horizontally. Then a jerk is produced. I think you can try this at home. I should move my arm horizontally. Suddenly means give one jerk, means like this. Then a pulse will propagate. You can see clearly these things. Okay, now how to calculate the time taken by the pulse to move from lower end to upper end? The linear density of a varies as mu equal to mu naught x. Find the time taken by the pulse to propagate through the length of the rope. Okay, again the same, the idea is same. So I'll assume a small elemental length of the rope at a distance x. Here t plus dt, here t and dmg. Okay, tt get cancelled, so this will be mu dx into g. What is value of mu? Mu naught x dxg. 0 to x. Okay, fine. This is like this. So then v equal to t by mu. So what is the expression for speed of the wave? Will be gx by 2. Mu naught get eliminated, x will get eliminated. Then this will write it as dx by dt. X to power of minus 1 by 2. So this will be root x, 2 root x, 0 to L. Shall we write here? Similarly, what happened to wavelength? Wavelength will change. So let me just show the broader pulse. That will be more justified. By the time the pulse reaches there, the one which is narrow, the wavelength has to change. The speed will change, wavelength, amplitude will remain same.
Sir, T is under root 8L by G, sir.
8L by G. Okay, now getting the idea, the rope, the tension, the rope can also vary. It's not that it should be fixed. It can also vary. The mu what will happen can be constant, can also be variable. Then we use this particular condition. Okay, we'll take the next, pulse wave propagation. Just is an independent topic. How to generate pulse.